Okay, this is exam number 1 for Physics 101 Fall 17. So which of these best approximates the area of one side of your calculator? I was sort of thinking about a TI-84, 5 or whatever. These are about 20 centimeters by about 10 centimeters. And so that's going to be zero point 0.2 meters by 0.1 meter, which is going to be 0.02 square meters, so 0.02 square meters. If you had a smaller calculator, they're not smaller by much. It's not going to be different by a factor of 10. In fact, there were no smaller values than this, so it would work for a smaller calculator as well. Which of these is a typical person's running speed? Well, let's see, 0.4 meters per second. That's kind of slow, and 40 meters per second is way too fast. But 4 meters per second, that's about right for just a typical person. They can cover about 4 meters in a second when they're running. Which of these equations is dimensionally correct? All right, let's look at this one. The x's, we can just cancel them, and I'm left with second squared over meters squared and second squared over meters, so not 1. So that gets rid of this one and this one. Let's look at these. Let's see, I can get rid of my m's here. That's all, and I'm left with meters per second squared, both of them, equals meters per second squared. That's x and a, so far we're good. And then meters squared per second squared. So 2 is okay, 1 is not, but 2 is okay, so that gets rid of D. Let's check out 3. I have meters. Remember, the 2's go away. Meters per second, seconds, that cancels, so far I'm good. And then I have meters. V is meters per second, but it's squared. And then I have A and X, second squared over meters, and 1 over meters. So meters. So that one's okay. So I have 2 and 3 is the right answer. A is the right answer for 3. The acceleration of object A is related to the velocity according to this. What are the units for the constant B? Well, A is equal to B times V. It's meters per second squared equals B times meters per second. So B is going to have to be 1 over seconds to make that dimensionally correct. How many sig figs should the solution for this have? Well, you sort of have to work this out. So if I do 12.25 divided by 4.92, I get 2.48. So I get 5.213 minus 2.48. And when I subtract these, I'm going to keep 2 decimal places, which will give me 3 sig figs. Standard for the second is based on cesium atom. Which of these is true? This came straight from your OpenStax. Metric system, the changes are based on the power of 10, but in the US, the British system, we have unrelated, so B is the right answer for number 7. This coordinate shows the location on a line. This is 5 units long, this is 2 units long. I want to know the angle here. Let's do theta is the inverse tan of 2 over 5. And I get 22 degrees. So this is 22 degrees plus 180 will give you 202 degrees, or just 200 degrees. And then also, what is the length of this line? Well, that's going to be the square root of 5 squared plus 2 squared. Square root of 29, which is 5.4. So A is the right answer. Speed limit on a highway is 90 miles per hour. What is this in meters per second? And in 1 mile, there are 1609 meters. And in 1 hour, there are 3,600 seconds. And so when I do that, I get 40. So that's number 10 is E. You throw a ball with an initial speed of 30 meters per second. How high does it travel? It goes up, comes back down again. Let's find the time up here at the top. I know that the velocity is equal to 0, and that's equal to v naught plus at. So I say 0 equals 30 meters per second. minus 10 meters per second squared. That's my acceleration times t. So t is equal to 3 seconds. I don't know how high it travels. So I say 30 meters per second times 3 seconds. That's the time to take to get up to here, plus 1/2 of a, that's -5, times 3 squared. That's 90 minus 45, which is equal to 45, or rounding up to 50 for 1 sig fig. Two bikes are 100 meters apart. They begin traveling towards one another. One travels with a speed of 4 meters per second. The other travels with a speed of 3 meters per second. How far apart are they after 10 seconds? It's kind of a good problem just to sort of think about. Can I draw a bike? Goodness. All right, here we go. That's fine. And then another bike over here. You get the idea. They're separated by 100 meters. One of these travels for 10 seconds. One travels for 40 meters per second, so they travel 40 meters. The other travels 30 meters. All right, I'm just doing x is equal to v times t to get these distances. So that's a total of 70. That means the separated distance between them is 30 meters. So number 12 is E. Motorcycle moves at a constant velocity, suddenly accelerates. So a is equal to 4 meters per second squared. To a speed, that's going to be his final speed, 35 meters per second. And t is 5 seconds. And I don't know what v0 is. I also don't know what x is, but it turns out I don't need that. So I say v is equal to v0 plus a times t. So 35 equals 0 plus 4 times t, so t is equal to 35 divided by 4, which is 9 meters per second. So 13 is A. Let's see, I have a mistake here. Let me pause here for just a second. Yes, I did have a mistake. You got to be careful. I mean, I even made this mistake. So it's actually 35 equals v0, and I don't know v0, plus the acceleration, which is 4, times t, which is 5. And then I find that v0 equals 35 minus 20. That's 15 meters per second. So the answer is not A, it's B. Sorry about that. Swan, a lake, gets airborne by flapping its wing and running at top of the water. This came straight from your OpenStax, by the way. Must reach a velocity of 4 meters per second. That's its final velocity. It begins at rest, so v0 is equal to 0. And acceleration is 0.2 meters per second squared. And I want to know what is x equal to. Well, x is equal to v0 t plus 1/2 at squared. This goes away because v0 is equal to 0. But I don't know t, so I need to figure out t because I don't know x and I don't know t. So let's look at our second kinematics equation. That's 4 equals 0 plus 0.2 times t. 4 divided by 0.2, that's 20 seconds. And then I take this and I plug it in up here, and that gives me x equals 1/2 of 0.2 times 20 squared. That's 0.1 times 400. That's 40 meters. So D is number 14. Drop 2 rocks off a bridge. The first one has twice the mass of the second rock. Which will have the greater velocity when they hit the ground? The one that, well, they both have the same velocity because they both fall with an acceleration equal to minus 10 meters per second squared. Which of these statements about kinematics is true? Speed is the magnitude of the velocity. That's true. Acceleration describes how the velocity changes with time. Hey, that's true too. Object with negative acceleration is always slowing down. Not true. In fact, you can have negative acceleration while it's speeding up. You drop something. Negative acceleration, speeding up. An object is speeding up. Its acceleration is always positive. That's also not true. So A is the right answer. You travel from A, you go to B, and then you go to C. What is the distance? What is the displacement? Well, the distance is 4 plus 2. So the distance is 6. So that gets rid of that one, and that one. And then my displacement is final minus initial. That's 1 minus 3, which is negative 2. Because my displacement is in this direction, 2 units to the left, or negative 2. So E is the right answer. Which of these, you drop an object, which of these best represents the position versus time graph? Well, first of all, when I drop it, it has a negative speed, a small negative speed, and it gets bigger. So this is going to be my small negative speed and getting bigger. C is the right answer. Describe the motion of time periods A, B, and C. Oh, goodness. Okay, so A, the object has positive acceleration. Well, it's positive velocity and slowing down. So no, it would have negative acceleration in A, so that's not right. We'll just get rid of that one. A, the object is slowing down. That's right. The object is speeding up in B. That's not true. It has constant speed because we have a constant slope there. The object has negative acceleration. Aren't we shown that? The object has zero acceleration. That's true because the slope is not changing. And then the object has a constant negative velocity. That's also true. So C must be the right answer. Let's just look at D, though. The object has a negative velocity. Nope, it has a positive velocity. So C is the right answer for number 19. Car has negative acceleration and positive velocity. Which of these position versus time graphs represents this motion? Negative acceleration and positive velocity. Well, because it has positive velocity, these go away. If it has positive velocity and negative acceleration, that means it's slowing down. So D, 20 is D. What is the instantaneous acceleration at point B? Well, I want to know the slope at point B, and so that's equal to 0. No, nothing more on that one. 22. What is the instantaneous velocity at t equals 7 seconds? T equals 7 seconds is right here. So find my slope there. It's going to be 2 over 1, or negative 2 meters per second. Number 22 is B. No, I'm sorry. Let's see, I did it to y'all because this is 1 unit and this is 2 units. So my rise, or excuse me, this is 2 units right here. So it's actually going to be not C, but B. Don't count the squares like I just did. Okay, you got to be more careful in that and look at the units to find out the rise and the run. So the graph of this velocity versus time, just estimate the distance it travels between 0 and 10 seconds. Well, in order to do that, we find the area of this section and the area of this section. Well, this section is has an area equal to 6 times 12. That's equal to 72. And this one has an area of 1/2 of 4 times 12, or 24. 24 and 72 is 96 meters. What is the average acceleration between t equal 2 and t equal 8 seconds? Well, a couple ways you can do that, or think about this. There's really only one way to do it. Between t equal 2 and t equal 8 seconds, A is equal to delta V over delta t. That is going to be VF, which is 12 minus 6, divided by delta t, which is 8 minus 2, which is also 6. 8 minus 2, and that's equal to 1. 1 meter per second squared. That, by the way, is the slope of this line. It's a slope of 1. Consider these two vectors. What is the direction of their sum, A plus B? Okay, so I have, let's draw a picture. 2 units on the negative y-axis. And then, oh, sorry, that's not what I wanted. Forget I drew that. 2 units on the negative y-axis, and then 9 units at 60 degrees above the plus x-axis. So 9 units at an angle of 60 degrees above the positive x-axis. So my resultant vector is going to start here and come up there. That's going to be my resultant. So it's going to be in the first quadrant. I can't really pick between these. So let's try to figure out what it is. So I'm going to find my components. AX equals 0, AY equals negative 2. BX equals 9 cosine of 60. 4.5, and by is 9 sine of 60, which is 7.8. Then I add up those y components and I add up the x component. So that's going to be ry is going to be 7.8 minus 2, that's 5.8. And rx is going to be 4.5. So if I want to know theta, let's say the inverse tan of ry over rx, which is going to be 5.8 over 4.5, get 52 degrees. That should be the answer. Yep, 52 degrees. Notice here, when I get the rx and ry, I had this is 4.5 and this is 5.8, and I was looking for this angle, so that's where that theta, the tan theta bit came in. So that is number 25 is C. 26, I want to do B minus A, where B is like it is, A is like that, and so that's going to be the result, so B is the answer. Vector has a negative x component, so the x component is over here, and a y component, and a positive y component. The magnitude of the y component is bigger than the x, so it looks like this. So my resultant is going to be here. It'll be closer to the y-axis than the x-axis. It's in the second quadrant. That gets rid of that, that, and that. It has to be 150 or 100. It's going to be closer to 90 than 180, so 100 would be the answer. All right. It can't be more than 135. So 27 is E. And then here, I just wanted you to think about, what you thought you made on this exam. I was just curious to see, how your actual grade aligned with your expectations for your grade. But, there is no right answer. But for me, I want the answer to be A. I want that to be not just in your thoughts, but in reality. So, good job.